So we're going to look at annuities broken into compound interest formula. Because there's technically a formula for annuities, but we're actually going to solve an annuity just using compound interest. And then maybe later we'll get into another lesson about an actual formula so we don't have to go through this long process. So this is going to be like a longer process to do it. So here's a question. You've decided to invest $500 at the end of a month in an account that pays 2% annual interest compounded monthly. It's a ton of information in one sentence. Determine the amount in the account after 4 months. Okay, so we have our compound interest formula. Okay, and essentially what's happening is we're going to break this down. Let's say today's the beginning of the month. So we have today. Okay, and then at the end of the month, so let's say end, or maybe actually a better word would be say month 1. Oops, today. Okay, and then at the end will be 1 month. Okay, we will have invested our money. So at the end of this month, we put in our $1,000. Okay, so this is month 1. So we plug in $1,000 into our account. Okay, and then after 2 months, oh, not 1,000. What am I saying? I said 500, right?
Yeah.
Yeah, I think that's what we said in the question. Sorry. $500. At the end of month 2, we plug in another $500, okay? And so on. So after 3 months, at the end of 3 months, we plug in another 500. And this will make sense. I just kind of want to set it all up for us. 4 months, and we said at the end of 4 months is when we're ending this, right? Okay, so, yeah, okay. So at the end of the 4th month. So what's happening here is essentially the first amount we put in is going to get compounded. And if we look at the amount of time that passes here, right, we have 1, 2, 3. So for 3 months, this amount is actually gaining interest. And then at the end of month 2, this amount for 1, 2 months is gaining interest. And then at the end of month 3, because we're putting in 500 every month, this guy for an entire month gains interest. And then at the end of month 4, we plug in $500 and it doesn't have the ability or it doesn't have the time to accrue interest yet. So essentially what we have to do here is we're going to get interest. So I'm going to say interest for 3 months, interest for 2 months, interest for 1 month, okay? And again, that's because we invested at the end of the month. So at the end of the month, this was only able to go 1, 2, 3 times, and that's why we save for 3. This guy's only 2, and this guy's only 1. And at the end of the 4th month, like we said, so we have to do 1, 2, 3, technically 3 compound formulas, and then we have to add the other one. We don't have to technically put this into a compound. So let's do the first one. We'll do the first one in purple, month 1. Okay, so our total amount is equal to the principal, which is $500, plus I. Now, I is going to be the same for everything, so let's do a quick calculation of what our I is going to be. I is actually the interest rate, which is 0.02, over the compound period, which is 12. Okay, so let's figure out exactly what that is going to be. 0.02 divided by 12, 0.0016, so equals 0.00167, we'll say. That's our I. So that's going to be our I in our formula, 0.00167. So we've got a pretty good rounding there. And N is technically how long it's in for times the compound period. Well, we know the compound period for this one is 12. How long this is in for? Well, our first version is only in for 3. So it's N times. Okay. Sorry, actually, it's not N times 3. Or 12 times 3. Our N, because we usually say 12 for the number of months in a year, right? But the thing is, we're only actually going for 4 months. So our N is actually just the number 4. It's not 4 times 12. That would be 4 years. So because it's 4 months, we don't put, or what we had before, sorry, in our case being 3, because it's all over 4, our N is not 4, but 3. Okay, so it's actually only 3 months it compounds for. If it was 3 years, we'd multiply by the 12 and get 36. But it's actually just 3 months, so we go to the power of 3. So it's actually going to be a lot less money here. So 500 times 1.00167 power of 3. So 502.50. So 502.50. Okay? So that's the first one. In our second one, which we'll do in green, so 2 months, for 2 months, A is equal to 500 times 1.00167 to the power of 2. Okay? We take this amount, 500 times 0.00167 power of 2. $501.65. So 501.67. 5. It's not a huge difference, but 67. Okay, good. So that's the second amount we put in. The third amount, let's do it in blue. Okay. It's only in there for a month. Okay, so A is equal to 500 times 1.00167 to the power of 1. To the power of 1 won't change anything. So it's the same as taking 500 and multiplying it by that. Okay, so this is our third one. 500 times 1.00167. Like I said, I don't need to put the exponent on because it's not going to make a difference. 500, we only earned 83 cents, right? So 583 cents. And finally, our last month, we'll do in red. This one, our amount is just 500 because it had no time to accrue interest. Okay? So what this annuity has done, we'll kind of highlight it, is we have to take all of these amounts, okay, and we need to put them all together to figure out how much money is actually in the account. Okay, because what's happening is we're putting more and more and more money, specifically $500 every month, into the account, and it's earning interest, and then we get interest on top of that. So that's what this whole idea was. So let's add up these amounts. When we add up these amounts, get our calculator out. So the first one's 502.50, so 502.5 plus 501.67 plus 500.83 plus 500. Sorry, I don't remember what the last one was. And it worked out to be exactly, wow, that's convenient, $2,005. So what we've got is our total annuity. Okay. Annuity in the end was actually equal to $2,005. And if you notice how much money we actually put in, well, we put in 5 plus another 5, which is 1,000. Another 5 is 1,500, and another is 2,000. So we actually put in $2,000. If I draw circles, it'll zoom in. And we earned $5 in interest in 4 months on this annuity. Okay.